So in this video I'm going to talk about the transformation of velocities. So let's say we have one frame S and another frame S prime, and this S prime is moving along the positive x direction with a constant speed v. And now there is another particle in space, and this particle is also moving, and let's say the speed of the particle is u, or the speed of particle is u in the S frame, and the speed of particle is u prime in the S prime frame. So now we can have two events. So event E1 is when this particle is at this location in S frame and at this particular time. That is, event 1 is when the particle is at x1, y1, z1 location and the time is t1. And event 2 is since the particle is moving, so after some time, let's say the time is now t2, the particle will have another location and this location will be x2, y2, z2. And similarly in S prime frame we can write these coordinates for the events. So this will be x1 prime, y1 prime, z1 prime and t1 prime. And similarly x2 prime, y2 prime, z2 prime and t2 prime. So this is how we define the velocity in a particular direction. So if it was the particle was in position x1 at time t1 and it was at position x2 at time t2, so the velocity along the x direction is given as x2 minus x1 divided by t2 minus t1. So this is the definition of velocity. So we can use this definition for y coordinate. So uy will be given by this expression and uz will be given by this expression. Also we can apply the same definition to the s prime coordinate system. So ux prime, that is the speed in the x direction in the s prime frame, will be x2 prime minus x1 prime divided by t2 prime minus t1 prime. But I can use the transformation equations to find the value of x2 prime and x1 prime. So from Lorentz transformation you know these relations. So x prime is equal to x minus vt into gamma and t prime is equal to t minus x v by c squared into gamma. So I can use these transformation equations. So x2 prime will be gamma into x2 minus v t2 minus gamma, and x1 prime will be gamma into x1 minus v t1. And similarly divided by, I can find the value of t2 prime and t1 prime using this transformation equation. So this gives me gamma t2 minus x2 v by c squared minus as it is, and then gamma t1 minus c1 v by c squared. Since we can take this gamma common from the above term and from the lower term, so it will get cancelled. So we are left with x2 minus x1. So we are rearranging this expression. So this gives me x2 minus x1 minus v t2 minus t1 divided by t2 minus t1 minus v by c squared x2 minus x1. So if I divide the above and lower term with a factor t2 minus t1, so I get this expression. So this gives me x2 minus x1 divided by t2 minus t1 minus v, and next we have t2 minus t1, so divided by t2 minus t1 will give me 1. So therefore in the numerator we will have, in the denominator we will have t2 minus t1 divided by t2 minus 1, so this gives me 1. So 1 minus v by c squared x2 minus x1 t2 minus t1. But what are these quantities? So these quantities are by definition the x component of velocity in the s frame. So therefore I can write ux minus v divided by 1 minus v by c squared ux. So now this is our expression which we have obtained. So this is basically the velocity transformation equation for the x component, and therefore and similarly I can use this transformation equation to find out the velocity component in y and z direction. So uy prime will be equal to y2 prime minus y1 prime divided by t2 prime minus t1 prime. But according to our transformation equation, y2 prime is equal to y2 and y1 prime is equal to y1. So therefore I will get y2 minus y1 divided by, so t2 prime we have already done this, so t2 prime minus t1 prime is given by this expression using the transformation equation. So we will have gamma is equal to t2 minus t1. Okay, so we will have y2 minus y1 divided by gamma t2 minus t1 minus v by c squared into x2 minus x1, and again I can divide the above and lower term with t2 minus t1. So this gives me y2 minus y1 divided by t2 minus t1 gamma times t2 minus t1 divided by t2 minus t1 gives me 1. So therefore we have 1 minus v by c squared x2 minus x1 t2 minus t1. But what is this y2 minus y1 t2 minus t1? So this is by definition the velocity component in the y direction in s frame. So therefore I can write uy divided by gamma 1 minus v by c squared ux, because this x2 minus x1 divided by t2 minus t1 is the x component of velocity in s frame. So this is our transformation equation for y component, and therefore for z component I obtained a similar expression, because y prime is equal to y and z prime is equal to z. So therefore if I replace here y by z, so I can get the expression for z prime. So these are our transformation equations for velocities. So if you have know the velocity in one frame, so you can shift your velocity into another frame. Also you can find the reverse transformation. I discussed this, that how can you find this. So all you have to do is to replace the y prime all you have to do is to replace the prime coordinates by unprime and v by minus v. So you can find the reverse transformation, that is that if this s prime frame is at rest and this s is moving along the negative x direction with speed minus v. So these are known as the reverse transformation equations. Basically these transformation equations are saying that if you know the velocities in the s frame and you know the frame speed with which the s prime is moving, so you can find ux prime. And therefore if you know the measurements in the prime coordinate, so you can also shift or you can also find the measurements in the rest frame. So all you have to do is to replace the prime coordinates by unprime and v by minus v. So that is all for this video.